okay, I've got a formula that tells me how to find the height of my rectangle based on the function that I'm graphing. Here, all of my rectangles happen to be underneath the graph of f. And I can actually find this area, right? My area is going to be equal to, what is it? I have the sum of 10 different rectangles. And each of the rectangles has the same width, 1/10. But the height of each rectangle could be different. The first rectangle has a height equal to the function f, evaluated at 2.1, times 1/10. And then I need to add to that plus f of 2.2 times 1/10. And I need to add to that, right? That's my area for the second rectangle. The third rectangle here is f at 2.3 times 1/10, and so on. And I could keep going here, f of 2.4 times 1/10, f of 2.5 times 1/10, and so on. But it's a lot faster to say that out loud than to type up this formula here. So the very last of these would be f evaluated at 3 times 1/10. Now, this formula is going to look similar when I take even more rectangles, but I'll have more things that I'm trying to add up. So to save myself from writing such a tedious formula where we all know what comes next, I just have to spell it out, we're going to take a detour into sigma notation so that we can write out very long sums without spending too much time on them. Now, you may have seen this in a previous class, or maybe not. Maybe I get to be the person who introduces you to sigma notation. The idea for sigma notation is that I want to explain there is a list of numbers that I'm going to add up. And the numbers on my list follow a specific formula. So the capital sigma here, this is the Greek letter sigma. It's the Greek equivalent of the letter S in the Latin alphabet. And S is for summation. When I write this capital sigma, I mean that I'm going to be adding up a whole bunch of things that follow the same formula. So here, I know that each of my rectangles has an area that looks like f evaluated at some number. What number is that? That number is 2 plus k divided by 10. How did I get that number? Well, I got it on my previous video. That's the height of my number k rectangle. What's the width of my number k rectangle? Well, they all have width equal to 1/10. So this formula here is telling us what kinds of numbers we will be adding up. Now, I need to tell you where to stop and where to start, right? We can only add up finitely many things together. So underneath the sigma, I'll tell you where to start or where to start. Here, the smallest k that I want is k equals 1. And then at the top, I will tell you where to stop adding things up together. K equals 1 gives me the area for my number 1 rectangle. here. K equals 2 gives me the area for my number 2 rectangle here. K equals 3 gives me the area for the number 3 rectangle, and so on. I stop at rectangle number 10. So this sigma notation is just representing a sum. We can add things together, but it's much more compact to write it this way than to try to write every single term out. I gave up after just 5 sum ends.